Tesla just leaked the engineering secrets behind their game-changing $25,000 Model 2, and it's not what anyone expected. This isn't just another cheap electric car. It's a complete reimagining of how vehicles should be built, maintained, and owned. From revolutionary crash-proof body panels that swap out like Lego blocks to a secret 48-volt electrical system that eliminates every car owner's worst nightmare, Tesla has solved problems you didn't even know existed. In this exclusive deep dive, we reveal the 5 breakthrough technologies that will make the Model 2 cheaper to own than any car on the road, gas or electric. Discover how Tesla's modular design could slash your insurance premiums by 20%, why their armor plating strategy eliminates expensive paint repairs forever, and how their sealed fortress underbody protects your investment from road salt, water damage, and electrical gremlins that plague traditional vehicles. The Model 2 isn't just Tesla's most affordable car, it's their smartest engineering achievement yet, designed to eliminate the hidden costs and headaches that have kept EVs from going truly mainstream. If you're considering any new car purchase in the next few years, this video will completely change your perspective on what affordable, reliable transportation shoe Tesla just revealed engineering secrets that could make their $25,000 Model 2 the most revolutionary car ever built, and it's not what you think. In the next 10 minutes, I'll break down the 5 game-changing innovations Tesla is using to make the Model 2 not just affordable to buy, but cheaper to own than any car on the road. From crash-proof body panels that swap out like Lego blocks to a secret 48-volt system that eliminates electrical nightmares, these aren't just upgrades, they're a complete reimagining of how cars should work. Welcome to Tesla Torch, where we dive deep into the engineering that's reshaping transportation. If you want to stay ahead of the EV revolution, hit that like button and subscribe, because what you're about to learn will change how you think about car ownership forever. Let's start with something that sounds almost too good to be true. Tesla has basically turned the Model 2 into a giant Lego set. I'm talking about their revolutionary bolt-on crash pod system that could save you thousands of dollars every time someone bumps into your car. Here's how traditional car crashes work, and why they're so expensive. When you get into even a minor fender bender, the impact energy doesn't just stop at your bumper. It travels through the entire front end, potentially damaging your radiator, cooling fans, headlights, and even structural components. What should be a simple bumper replacement becomes a $3,000 nightmare involving a dozen different parts and a week in the shop. Tesla completely flipped this script with the Model 2. They've designed the body as 3 main sections, front, middle, and rear, with special crash pods bolted on at the most vulnerable points. Think of these pods as sacrificial shields that are designed to absorb all the impact energy and protect everything behind them. When you get rear-ended or bump into a parking barrier, the crash pod takes the hit, crumples exactly as designed, and keeps the damage contained. Instead of replacing half your front end, a technician simply unbolts the damaged pod and bolts on a new one using the same standardized torque specifications they already use on the Model 3. The entire repair can be done in a couple of hours instead of a couple of days. But here's where this gets really interesting from a cost perspective. Insurance companies love predictable repair costs. When they know that most minor collisions will result in a simple module swap instead of cascading damage throughout the vehicle, they can offer lower premiums. Tesla estimates this could reduce insurance costs by 15 to 20% compared to traditional vehicles. Now, Tesla didn't stop there. They also completely reimagined what the outside of a car should look like when you actually use it every day. The upper portion of the Model 2 is traditional painted steel that looks beautiful and clean. But everywhere your car actually gets beat up, the bumpers, the lower door panels, the wheel arches, Tesla has covered with textured, unpainted polymer cladding. This isn't just about looks. This is engineering genius disguised as design. These lower sections are made from engineering plastics like polypropylene with UV stabilizers that can take a beating and keep looking good. The textured surface doesn't show scratches the way smooth paint does. It doesn't collect dirt and grime. And when you inevitably scrape against a curb or get dinged by a shopping cart, the damage either doesn't show or can be buffed out with minimal effort. But the real magic happens when this cladding actually gets damaged. Instead of taking your car to a body shop for painting and color matching, A technician simply releases some clips and screws, pulls off the damaged piece, and snaps on a replacement. No paint booth, no drying time, no color matching issues. The repair can often be done in your driveway. Over 5 to 10 years of ownership, this adds up to massive savings. No more $800 paint jobs from parking lot dings. No more rust starting from stone chips on your lower panels. The car looks newer longer, which means higher resale value when you're ready to move on. Think about it. How many times have you looked at your car and sighed at some scrape or chip that would cost more to fix than it's worth? Tesla just eliminated that problem entirely. But Tesla's real engineering breakthrough is hidden underneath the car where you never see it. They've created what's essentially a fortress, protecting all the expensive stuff. The Model 2 features a completely sealed underbody with a flat battery floor. This isn't just about aerodynamics, though the improved airflow does help with range. This is about creating an IP67 rated barrier between your expensive electronics and the hostile world of road salt, mud, gravel, and water. Traditional cars have dozens of openings underneath where moisture and dirt can get in and cause problems. Electrical connections corrode, metal components rust, hoses and cables get damaged by road debris. Over time, these little problems add up to expensive repairs and mysterious electrical issues. Tesla sealed all of that away behind protective panels, but they were smart about it. They included strategically placed service hatches that allow technicians to access key components from below without having to tear apart your interior. This means routine maintenance and repairs are actually faster and cheaper, not more complicated. The battery pack itself meets IP67 standards, which means it can be submerged in a meter of water for 30 minutes without damage. But beyond water protection, this sealed design keeps out dust, salt, and debris that would normally cause long-term degradation of electrical connections. Here's where Tesla's structural engineering gets really impressive. By making the battery pack a load-bearing part of the car's structure, they've eliminated about 10% of the vehicle's weight while increasing structural rigidity. This translates to up to 14% more range and hundreds fewer parts that could potentially fail. When service is needed, technicians can access most components from underneath the car using those service hatches. This means faster diagnostics, quicker repairs, and less time with your car torn apart in a shop. Many routine maintenance tasks that used to require removing interior trim and dashboard components can now be completed from below in a fraction of the time. But perhaps Tesla's most revolutionary change is one you'll never see: the complete redesign of the car's electrical system around a 48-volt backbone instead of the traditional 12-volt setup every other car uses. Here's why this matters more than you might think. When you need to move a lot of electrical power, say 960 watts for your seat heaters, cooling fans, and infotainment system, a 12-volt system needs to push 80 amps through thick, expensive copper wires. Those high currents create heat, require bulky connectors, and cause voltage drops that waste energy. The Model 2's 48-volt system only needs 20 amps to move that same 960 watts of power. Lower current means thinner wires, smaller connectors, less heat, and dramatically reduced power loss. But the real genius is in how Tesla implemented this system. Every major component, seats, fans, pumps, motors, connects to the 48-volt backbone through standardized waterproof quick disconnect connectors. When something fails, a technician doesn't need to trace wires through the entire car or diagnose complex electrical interactions. They can simply unplug the failed component and plug in a replacement. Tesla estimates that most electrical component swaps can be completed in 30 to 60 minutes, often through their mobile service program. Instead of scheduling a day at the service center for an electrical problem, you might get it fixed in your driveway during your lunch break. The system uses electronic fuses and sensors to monitor every branch of the electrical network. When something goes wrong, the system immediately isolates the problem and logs detailed diagnostic data. No more mysterious electrical gremlins that take hours to track down. No more intermittent problems that only happen sometimes. The car essentially diagnoses itself and tells the technician exactly what needs to be replaced. For components that still need 12 volts, like some legacy electronics, Tesla uses local voltage converters right at the device. This eliminates the long wire runs that cause voltage drop and heating in traditional systems. Connections stay cooler, oxidation is reduced, and reliability goes way up. Now, let's talk about something every EV owner worries about. What happens to your range when it gets really hot or really cold? Tesla has engineered a solution that's so elegant, it seems obvious in hindsight. The Model 2 has a single integrated HVAC module mounted in the front that handles 4 critical functions. It cools your cabin in summer, heats it in winter using an advanced heat pump, removes humidity to keep your windows clear, and manages the temperature of your battery pack for optimal performance and longevity. The secret sauce is Tesla's evolved version of their octo-valve concept. A multi-port manifold that can route refrigerant and coolant wherever it's needed most. Need to cool the battery during fast charging while heating the cabin? No problem. Want to preheat the battery while you're still plugged in at home? The system handles it automatically. Here's where the heat pump really shines. Traditional electric heaters in cars work like a giant hairdryer. They convert electrical energy directly into heat with about 100% efficiency. It sounds good until you realize you're using battery power that could be moving your car to instead heat the cabin. Tesla's heat pump system can deliver a coefficient of performance around 3 to 4, meaning it moves 3 to 4 times more heat than the electrical energy it consumes. Instead of converting electricity to heat, it's moving heat from one place to another, just like your home's heat pump or air conditioner. In real-world testing, heat pump EVs retain about 83% of their rated range in freezing conditions, compared to just 75% for EVs without heat pumps. That 8% difference might not sound like much, but it's the difference between making it to your destination and searching for a charging station in a snowstorm. The system also handles dehumidification, which sounds minor until you're driving in humid conditions with foggy windows. By controlling humidity, the system keeps glass clear, reduces odors, and helps wet surfaces dry faster. It can prioritize cabin comfort when you need it, or focus on battery thermal management during fast charging or extreme weather. From a service perspective, Tesla designed the HVAC system around a cast manifold with standardized ports. Instead of chasing refrigerant leaks through long hose runs or diagnosing problems across multiple valves and sensors, technicians can access, test, and replace specific subassemblies quickly. Fewer joints mean fewer potential leak points and easier refrigerant handling during service. So what does all of this engineering actually mean for you as an owner? Tesla has fundamentally changed the economics of car ownership by addressing the hidden costs that add up over years of driving. Those bolt-on crash pods mean your minor parking lot mishaps become quick, predictable repairs instead of insurance nightmares. The rugged cladding keeps your car looking good with virtually no maintenance, protecting your resale value. The sealed underbody shields your expensive components from the elements, preventing the gradual degradation that leads to mysterious problems years down the road. The 48-volt electrical system eliminates the wiring complexity that causes random electrical failures in traditional cars. When something does go wrong, it's diagnosed instantly and fixed quickly, often without a trip to the service center. The integrated HVAC system delivers better performance while using less energy, and when service is needed, it's straightforward and predictable. Insurance companies are taking notice. When repairs are faster, cheaper, and more predictable, premiums can come down. When cars are less likely to suffer total losses from minor accidents, rates stabilize. Early estimates suggest Model 2 owners could see insurance costs 15 to 20% lower than comparable vehicles. But the bigger picture is what this means for EV adoption. Tesla isn't just making the Model 2 cheaper to buy. They're making it cheaper and easier to own than any car on the road. For mass-market buyers who have been hesitant about EVs due to concerns about reliability, repair costs, and complexity, the Model 2 directly addresses every one of those worries. Tesla is building the Model 2 on existing production lines alongside current models, which means they can leverage proven manufacturing processes while implementing next-generation platform improvements. This strategy keeps development costs low and enables faster production ramp-up, making the $25,000 target price achievable from day one, not years down the road. If Tesla delivers on this vision, 2026 could be the inflection point where EVs truly go mainstream. Not because they're trendy or environmentally conscious, but because they're simply the smartest financial choice for everyday drivers. The Model 2 isn't just Tesla's most affordable car, it's potentially their most important. By solving the real-world problems that have kept some buyers on the sidelines, Tesla is creating a vehicle that's not just electric, but actually better than what came before. For drivers tired of unpredictable repair bills, complicated maintenance schedules, and cars that seem to develop new problems every year, these innovations represent something revolutionary, a car that's designed to be worry-free. Whether you're considering your first EV or you're a longtime Tesla fan, the Model 2's engineering could set the standard for what affordable, reliable transportation looks like in the electric age, and that's a game-changer worth paying attention to. That's a wrap on today's deep dive into Tesla's Model 2 engineering. If this kind of detailed analysis is what you're looking for, make sure you're subscribed to Tesla Torch and hit that notification bell so you don't miss our latest breakdowns. What feature are you most excited about? Let me know in the comments below, and I'll see you in the next one.